The second rule in the properties of exponents is the power rule. And here's the setup. I've got an expression in parentheses, and I'm raising it to a power outside the parentheses. So this is really, it's actually easier to learn this. Let me give you the basic property, and then we'll do a little example. When I have this scenario, when I have the power raised to a power, I simply multiply the two powers together. So the first property we added together, now we're going to multiply them. And that happens whenever I have the exponent inside parentheses, and then I'm raising it to an exponent right outside the parentheses. I can actually just multiply those two together. And I want you to add one piece to this. If I have a product inside parentheses, let's say I have x times y, and I'm squaring it. That means that I'm going to square the x and I'm going to square the y. And the operation between them remains multiplication. I'm not adding them together. So this would be a product inside parentheses raised to a power. And let's go one more layer with this example. Let's say I had 2x squared y, and I'm cubing the entire thing. That means that each factor inside the parentheses would take the power of 3. And then I would have x 2 times 3, and then y cubed. And then I would go ahead and make that 8x6 y cubed for my simplified answer. So here the most basic example is the one that's presented on your paper already, x raised to the power of a and the whole thing raised to the power of b. The way you would apply the property is to write the base of x one time and then you multiply the exponents together. But oftentimes you have a product inside the parentheses and you need to think of distributing that power to each term inside the parentheses. And let's look at a few of these together. So here's my example, and I'll show you why it works. This is x squared raised to the third. So this is really x squared times x squared times x squared, 3 times. Because remember, the exponent tells you how many times you're going to multiply that base times itself. If I present this written out in this manner, then it's easy to see that I would write the base one time, and then I would use the first exponent property, which becomes x raised to the power of 6. But in order to save time and work in a more efficient manner, the reason we're allowed to multiply 2 times 3 is because of the expansion that I'm showing here. So really, I would just think of this as the base of x raised to the power of 2 times 3, which would be x raised to the power of 6. This is why it works. This is why it works, all of this. But for the sake of efficiency, to apply the property, here you're applying the property. But it's always nice to know why something works. So here you're applying the property. The reason you're allowed to apply the property is because of what I've written in the expansion. Let's look at the second example. So here I have my little expression right here. I've got my negative base raised to an even power, so that's going to become positive. And I'm going to have 2 squared, and then I'm going to have m to the 5th, and I'm squaring that again. So my new property tells me that I multiply these. So this becomes m to the power of 10. And then I have m cubed sitting here, and now it's time to use the first property. So you apply the properties, and oftentimes you have problems where you incorporate several properties at once. So here, to simplify this, 2 squared is 4. I write the base of m one time. When the bases are the same, I add the powers. So my simplified answer becomes this. And I've used a few properties in one single problem. So let's look at some of the exercises with this to make sure that you get practice and get a good explanation. And here are some basic problems. Let's see, I'll go to this. Let's do some of these. Basic, okay? Number 1, the most basic example of all. So this would be another chance. I will write this in its expanded form just to make sure that you've had a chance to see this. And you don't have to do this, but I'm just explaining once again why it works. So this notation is telling me to take x squared and multiply it times itself 5 times. So to use the first property of exponents, that means I would be adding 2 to itself 5 times. And this is going to give me x raised to the power of 10. But I can get there in a much quicker manner if I just simply multiply 2 times 5 and arrive at x raised to the power of 10 by multiplying the exponents together. So what's written in red is why it works, but what's written in blue is the property that you can use. Let's look at number 2. So here I'm cubing, and here you can see I have 2 things in the parentheses. So each factor inside the parentheses will take the third power. And the d would be 2 times 3, so that would be raised to the power of 6. And let me clean the board up a little bit, and we'll do a few of these together. Let's look at number 4 together. This expression is raised to the 5th power, so I've got 2 raised to the 5th. X is already squared, raising it to the 5th, so I'm multiplying, and then y raised to the power of 5. And then I would go ahead and write 2 to the 5th as the number 32, x 10, y 5. Let's do one with the fraction in it. Let's do the negative and let's do the fraction, and then I'll stop the video. So here I've got the odd power, the negative base. So that tells me that my product is going to be negative. I would apply the cube to the base of 3, and then I'm going to multiply the 2 and the 3 together on the x to get the power of 6. So this final answer would be negative 27 x raised to the power of 6. And then let's do the fraction, same thing. I'm going to have 1 cubed over 2 cubed, and 1 cubed is really just 1. So I'm just going to apply that to the 2. And then I would have a, and I multiply these together, and b, that's 4 times 3 is 12, and 5 times 3 is 15. So the simplified answer here would be 1/8. And I'm going to write this as one fraction because I would like for you all to get comfortable with that. So I'm going to write this. This is going to be my numerator. And then my denominator is simply going to be 8, or 2 cubed. And I'll stop the video here and let you all practice this property.